Hello and welcome to another tutorial. We're going to continue our discussion on classes and objects in Java, and let's have another look at access modifiers for members of a class. And remember, members of a class are the member variables or the data or the non-static state that the object holds, which are also called fields, right? Member variables are called fields usually in Java, and member functions, which are called methods in Java. And the reason that we don't use member function terminology is because everything in Java has to be in a class, right? You cannot have a freestanding function by itself, right? There is no global scope outside the scope of any class. So you have to always be inside the scope of a class, but then a class can allow functions that are general purpose and don't really rely on the state of object, and they are called static methods. So static methods are the closest things that we have in Java to freestanding functions, for example, in C++ or Python, right? So access level modifiers determine whether other classes can use a particular field or invoke a particular method. And not only this was, so remember, this whole business of access modifiers and restricting the access is because of one of the main pillars of object-oriented programming, which is called data encapsulation. Data encapsulation means you hide the internals of your class and objects as much as possible and only expose the people who use your classes, only expose the parts that are really necessary for others to interact with your classes and objects. And that's one of the best practices, and that makes a lot of sense. Sometimes and obviously, again, the best practice is always don't really expose any internal fields or member variables. Always let others to interact with your objects via the methods. And then as long as you keep the signature of the method the same, you are allowed to change the internals. And because people don't really access the internals, they just interact with the method. They're called methods. As long as that method, the return type, and then the signature, what parameter it takes, is the same, you can even go and change the implementation of that method, and others people code will just work. And that's one of the beauties of object-oriented programming and data encapsulation. There are two levels of access control. At the top level, you have public or package private, and I also call this default access level. If you don't write any explicitly modifier for a field or a method, it is assumed to be package private, package level access, which means other types, classes, interfaces, anything in the same package, they can directly access those fields, for example, or methods. They can but other classes or other types in other packages can never access the package private levels, right? At the member level, so okay, so this top level actually corresponds to the type, and this is something that I mentioned before, which is a very, very important concept. And the concept is that if for other classes to be able to access, for example, basically there are two levels. One level is for other classes to be able to access the type itself, because when you declare a class like this animal, you can declare it as public or no type. You cannot type private or protected for the type itself. A type can either be public or package level or package private, which means and this restricts access to the type itself. And we said that this is important because sometimes other classes don't really want to create any object of this type, but they, for example, want to declare a method that take a parameter of this type, right? This is still possible. But then if those classes don't have access to the type itself, they're not allowed to have a method that that takes a parameter of this type. So accessing the type itself is different from accessing the state or the member variable or the fields and methods, right? Or even the constructor, because the type might be public, everybody can access the type. For example, everybody can declare a method that takes a parameter of the particular type that is public. But for example, if the constructor of that type is private, nobody can use the new operator to create an instance of that type, right? So accessing the type is important by itself because sometimes other classes need to declare a method that takes a parameter of that type. So if the type is not public, then other classes might not be able to access the type. So at the member level, public, private, protected, or package private, or no explicit modifier, or default. I also call this default. We've seen in Eclipse the color coding. I'm going to show you one more time again. Green means public. If there is a field circle, it means it's a method. If there is a white dot inside of it, it's a field. And then a rectangle, a blue rectangle means a package level access or package private. As you can see now, we have this a blue rectangle here next to animal class. All right, and then public is green, private is red, square red. As you can see, this one changed to red. Right now we have a warning sign, but that's fine. There is a red square, which means this is private. And then protected is a yellow diamond. Protected, it's a yellow diamond, as you can see here. So this color coding is very nice in this outline view. It immediately tells you the member functions, member variables, and also the access modifiers. And obviously no access modifier, no explicit access modifier means it's a package level access or package private, which is in Eclipse, it's a blue rectangle. So not only the color is different for these 4 different access modifiers, but also the shape is different. So 2 ways to immediately tell whether to immediately look at this outline view and see which ones are public, which ones are private. Even the class itself, as you can see, it's green. And then basically it doesn't have a triangle like this, right? If it has a triangle, it means it's a package level access or package private. If it doesn't have, then it's public. So type can either be public or package level. Now with the introduction of module, now we have more control over who can access public types. So modules are something that we haven't looked at, but modules provide another level of restricting types. Right now, in the legacy Java, in the old system of packaging, then it's just either public or package private. And if you mark a type public, everybody outside, everybody in any other package can access it. So there is no other restrictions. So it's public to everybody, or it's only accessible by the classes in the same package. Sometimes this is not the desired behavior. Sometimes you want something in between. For example, you're working on your Java project. You want a types in a particular package of your project be able to access other types in other packages, but you don't want to open the type actually to everybody, right? You want to really restrict it to a couple of packages in your projects. Then you can come up with some sort of module, because with modules now, packages or modules can interact with each other, allow each other's type to be accessible without allowing everybody else to access them. So packages, there's also another concept in most recent version of Java called sealed classes, right? The keyword sealed was added. Now obviously this complains because sealed classes basically sealed classes have restrictions. They kind of have to be final, and they have to have some classes. So we will look at the sealed classes in the future lectures, but for now we are just reviewing the basic concepts. And then right now you can assume that either a type can be public or package level access. A class may be declared with modifier public, in which case that class is when we say class, just replace this terminology with type, because I've mentioned this before. The terminology type is a more general terminology than a class, because same with interfaces can be public or dev package level access, right? Every type can be either public or package level access. So it's not just class, we're talking about interfaces, enums, etc. Is visible to all classes or all types everywhere. If a class or type has no modifier, the default, also known as package private, it is visible only within its own package. Packages are named groups of related classes. We had a in-depth discussion of what packages are, what is the relation between packages, fully qualified names of types, and then the class path. At the member level, you can also use the public modifier or no modifier package private, just as with type level classes, and with the same meaning for the members. By the way, in Java, every field and any method has to have its own its own modifier. So I think I mentioned this before, For example, in this example, in C++, usually you write public and then colon, and then you say int x1, I don't know, double x2, etc. And everything that is below this public is considered public. But so this is like the C++ way, right? And we discussed this before. The Java way, Java said, okay, this causes confusion, so let's just say that everybody has to have its own modifier. So in Java, you kind of have to write this explicitly, like public int x1 and then public double x2. So everybody has to have its own explicit way of saying the access modifier. So that's the difference. So we also, for the member variables like fields and methods, we also have two other modifiers, private and protected. The private modifier specifies that the member can only be accessed in its own class. So really, as long as you're physically within the scope of the class. So whenever something is private, nobody, not even subclasses, are allowed to access them. If somebody inherits from your type, the private part of the state of your type is still part of the state of subclasses. So I want to be clear about this. Whenever somebody inherits from your class, they inherit all the state, even the private parts, but they're not allowed to touch it. So a subclass is not allowed to touch the private state or private part of the superclass, although it's also part of the state of the subclass, but they're not allowed to touch it, right? The protected modifier specifies that the member can only be accessed within its own package, as with package private, and in addition by a subclass of its class in another package. Now, exactly in opposite to private, we have protected, because private didn't allow even subclasses to touch the state, but that's why we use protected. Whenever you have protected, it's very similar to private. Nobody else can touch it unless it's a subclass. So subclasses are allowed to touch the protected part of the state of the superclass. So normally, whenever we try to stay with private, we try to declare all the fields as privates. Now remember, fields are what actually defines the state of the objects, right? Your class. That's why we try to keep it private. Methods, they're typically public, because those are the methods that methods are actually the way for others to interact with our class. So methods are typically public, fields are typically private, and then in special cases, some methods become private, some fields or methods become protected. Normally fields become protected, etc. The following table shows the access to members permitted by each modifier, and we looked at this before. So a public for a field or method, a public modifier allows for the class itself, every other type in the same package, every type of everybody that inherits from your class, and void. Void means everybody else in another package, in another project, everybody on the class path. Let's say it like this. Every type on your class path is allowed to access the public members of your class, right? When we say void, it means every type that the JVM can find at runtime, or the Java compiler can find at compile time. And these are the things that the Java compiler and JVM have to search for on the class path. Protected, classes and packages and subclasses. Private, only class, right? So protected also allows, so protected is one level below public, because subclasses are allowed. And then no modifier, or the package private modifier, is one level below protected, only class and package. And then the private doesn't even allow subclasses or other types in the same package. The first data column indicates whether the class itself has access to the member defined by the access level. As you can see, a class always has access to its own members, which makes sense. I mean, if it wasn't like that, then that would significantly question the whole data encapsulation. So whenever you are inside the class itself, you have access to all of its member functions, because you have to, a class itself has to be able to access its own state, right? Otherwise it's very weird, right? And so we have these access modifiers, and I wrote that here, right? These are the state. these 4 variables define the state of this class. One of them is public, the other one is protected, the other one is private, and this last one is basically, if you look at the outline, it's a triangle blue, which means it's a package level access. So from the most accessible is public, least accessible is private, and private you are only allowed to use it within the scope of the class itself. Now we saw a very interesting use of private, and is that if your class, your type, defines a method that takes a parameter of the same type. So this class, this type is called access modifiers, and the parameter of this type is also the same of this method is also access modifiers. Now you are allowed, so this is a parameter that is a variable that is going to be passed at runtime, but you are allowed to access its private parts because you are still physically within the scope of your own type, of this own type. That's why this is a very nice trick that we use when we want to define a method that takes another parameter of the same type, and we access the private part directly, and then combine it with the state of the current object, and then return some calculation or something, right? So this is one interesting use case of the private part if the parameter is the same type. The second column indicates whether classes in the same package as the class regarding of their parentage have access to a member. And remember, the idea of package was to group related types together, and therefore they should have a reasonably tight connection with each other, which means typically we want to allow types in the same package to access internals of each other, access each other's members directly. That's just because they are in the package, in the same package for a reason, and the reason is that they are supposed to closely interact with each other. All right. The third column indicates whether subclasses of the class declared outside this package, or maybe inside the same package, it doesn't matter, have access to the member or not. The fourth column indicates whether all classes have access to the member. And when we say all classes, it means all the types that are on the class path that the Java compiler and the JVM can find, right? And where to find the classes? They find it on the class path. Every folder, every directory that is on the class path is searchable, and JVM, whenever you specify a type, the fully qualified name, JVM starts from the top level of the class path, all the folders, and then it goes into them and finds the actual type. Access levels affect you in 2 ways. First, when you use classes that come from another source, such as the classes in the Java platform, the JDK, the standard classes that come with the JDK, access levels determine which members of those classes your own classes can use. And again, when we say class, replace it with type, interface, class, enum, etc. Second, when you write a class, you need to decide what access level every member, variable, and every method in your class should have. And the default is this: member variables or fields are private by default. You should declare them private unless there is a good reason. And methods are typically public because that's the way that others interact with your class, unless there is a good reason to make them private or protected or package level access, right? So methods by default public, especially setters and getters, they're supposed to be public. And then fields are private by default. Tips on choosing an access level: if other programmers use your class, you want to ensure that errors from misuse cannot happen. And this is again one of the reasons of data encapsulation, object-oriented programming. Access levels can help you do this. Use the most restrictive access level that makes sense for a particular member. Use private unless you have a good reason not to. Again, best practices. Avoid public fields except for constants. Public static final. These are called constants. Many of the examples in the tutorial use public fields. This may help to illustrate some points concisely, but it is not recommended for production code. When we say production code, the code that is part of a large project, for example, that companies use. Usually, I mean, everybody writes a small, owns a small part of the code or the classes of a very large project. And Java is designed to have lots of restrictions in a way that it makes a large project easily maintainable, especially with the great IDEs that we have. So this is not a good practice because public fields tend to link you to a particular implementation and limit your flexibility in changing your code. What this means is that As I mentioned, it's always the best practice to make every field private, and then have if you want somebody to access this private field, create a public getter, this is int get x3, for example, right? And then return x3. Now, the reason this is the best practice, because now you can change the internals of this class without anybody noticing this. So let's say somebody else calls this get x3 and they just expect to get some int, right? But let's say at some point you decide that, okay, maybe x3 was not a good name, maybe x3 a better name. It's something you want to change. This is called refactoring the code. As long as you change this one, as long as you maintain the public API, like you don't change the name of the x3, but maybe this you decide that, oh, there was a bug, maybe you have to return twice times x3, for example, or maybe you decide to rename this x3 variable which was internal, which was a private. Yeah, sometimes you find a bug or something. As long as you don't change the signature of the public API, public getter, nobody notices that, and other people's code just work fine. So you debug your class, you realize that you had to add multiply this x3 by 2 for some reason, right? Sometimes this happen, but nobody notices them. They just write their own code, they still call get x3, and now their code works without any bug, right? So data encapsulation and making all the fields private. But obviously if a field is public, other people can directly access it. So first of all, you probably will never be able to rename this variable, because if you rename it and other people directly access x1, then their code is messed up. They have to refactor their code. So the idea of object-oriented programming, data encapsulation, all these access modifiers, is that you want to define a set of very restricted public API that other people can interact with your class. And then you promise that you never change the public API. I mean, changing the public API, like public int get x3, it obviously causes other people to change their code if they're calling this method. So you promise that you most likely never change the public API of your class. That's why we say that restrict. Try to have minimal number of public methods and try to not have any public field, right? You want to make sure that your hands are very open in terms of evolving the class, changing the names, changing the internals, as long as the public API doesn't change. That gives you, as a developer, the most flexibility. And trust me, that could save you a lot of headaches down the road if you stick to this principle, right? So again, avoid public fields except for constants. What do we mean by constants? Constants are public static final fields. So we've seen this before. So these are called compile time constants. Public static final, let's say some number. And typically these are all caps. Some number is 5. And we have to say it's, for example, int. So to compile time constants, these are int, some number equals 5, right? And the convention is that these are public static final. We know that if a variable is final, its value is never changed. If it's a static, it means other people, it doesn't belong to the state of the object, right? You have to initialize it as long as you define. So if I don't do this, it's going to give me a compilation error. Now, if it wasn't as final, we can still, we have to initialize this somewhere in the constructor, because this is part of the state. And whenever the state gets initialized, whenever somebody calls a constructor, that's why a non-static final field has to be initialized in a constructor. But a static final field, because it doesn't belong to the state of the object, it has to be initialized as soon as you define it. There is no other way that is allowed. And then public means, okay, first of all, this is final. So if a value is assigned to it, nobody can change it at any time. A static means it doesn't belong to any particular object. Public means everybody can access it, because if it's final and a static forces us to immediately initializes it, this is it. This variable and 5 are synonymous. So I'm going to write it down. Compile time constant means variable and the value that it holds, like 5, are basically synonymous. What this means is that let's try to have a public int method or get constant, right? And then we're going to return some number. Now notice the bytecode. So let's go back to the bytecode access. So we are in the classes package. So let's go to the bytecode. Let's look at the access modifiers, and you can probably guess what happens in the bytecode and why we call this a compile time constant. The compiler will replace everywhere that compiler sees this value, it replaces with 5, because there is a 100% guarantee that this variable, it always holds the value of 5 and nobody can change it. So if you go to the get x3 get constant, note that what happens. The compiler just say load constant number 5 and then return an integer which is 5. That's it. Which means the compiler replace this value at compile time with number 5. There is no name, there is no mention of loading this variable or searching for this variable, right? So right now we are in the same class, but we can go in another class and do the same thing. Public void read constant. And say access, remember static fields, we access them via the static, and then we say we assign it to some x value. All right, now let's go to access modifier demo 2, and you will see that what happens in the bytecode is the compiler, instead of trying to find this type and then see what value this variable holds, the compiler replaces this whole thing with literal 5. So let's see. So as you can see, the bytecode here is load the constant 5. Where is it coming from? It's coming from this variable, which was a compile time constant, iconst 5, and then store it in variable x. That's it. Which means the compiler at compile time. This has nothing to do with the JVM, right? At compile time, the compiler said that this line of code is equivalent to int x equals 5. That's the meaning of compile time constant, right? And you will see a lot of these compile time constants in Java, even in the JDK classes. Usually in other programming languages like C++, you put this in a global scope. It doesn't belong to any class. In Java, we don't have a global scope, so they have to be in a scope of some class. And you put them in some class that makes more sense. Let's say this class is a window, a GUI, right? A window, and the window has some constant properties. So you put the constants in the window class, for example. So I hope you enjoyed this lecture. Now have a very solid understanding, or maybe this was a refresh for you in terms of reviewing your knowledge of access modifiers. Please stay tuned, and I'll see you in the next one.